A really warm welcome to our Climate Challenge conference. It's very, very good to have some friends here from the Collective de Climato-Realistes, that's it, yes. And forgive our English, we will do our best. I have on my screen, is it coincidentally, a bridge that was built in the 19th century in Britain by a man who was half English and half French, Isambard Kingdom Brunel. His father, Marc Brunel, was a Frenchman, and so that's very appropriate, I think, for our meeting. Now, first of all, some nuts and bolts and so forth. This book is available for free. If you want to take a number of copies for other people, please do that. So these are for free. We also have a tie, which some of us are wearing already. I've given it to some folks who it's their only payment, no, that's not quite true, but for coming if they're speaking. But if you're prepared to contribute towards it, I think I'm charging as much as €20 for it, or £15 if you work in English money, and if you work in Canadian or American dollars, oh well, forget it. We can work something out. There are books available too. I've got a few copies of Andrew Montford's account of the email leak, Hiding the Decline, the Climate Gate affair. James Delingpole, sitting at the back there, invented the name Climate Gate as a journalist, so it's good to have him with us. What I do not have, I only have a sample copy because I think you guys in France will be able to get it, and anyway it's in French, which I struggle, it's good stuff though to do that. Philippe Verdier, the weather forecaster, who of course lost his job for daring to publish that. As always, as one of the organisers, nothing like trying to flog your own stuff. I wrote a book about the whole wide issue of climate change, partly from my Christian perspective, and trying to talk to my fellow Christians on the issue. The title is While the Earth Endures, Creation, Cosmology and Climate Change. There are copies of that at the back, and I'll part you some money if you want to buy them. Go that foolish. I also have a summary of Professor Murray Salby's lectures, his first set of lectures in 2013. I'll briefly touch on some of his material in my talk. We may have time to watch his full second lecture, which he did earlier this year, on the issue of where the CO2 is coming from, what it's doing, and where it's going, I suppose is the right way to put it. But there are copies of that at the back as well. There's also a copy of a little amusing story I wrote called A Climate Carol. I couldn't help, there was some loony at NASA who apparently as a hobby ghostbusted. Yes. But it put me in mind of Dickens and the ghost of Christmas past, Christmas present, Christmas yet to come. And I thought, yeah, the ghost of climate past, climate present and climate yet to come, based around poor George Monbiot of The Guardian, though I do not name him for libel reasons, who acts as the Scrooge of my tiny tale. Now, the timetable is the one in red, white, and blue, or blue, white, and red, should I say, which supersedes what's actually printed in the book. When we went to press, we just had to go with what we had. So if there should be if you haven't got it, that's what it looks like. So that's that. Well, I think it's all right with you guys. With no further ado, I'll briefly introduce myself, Mr. Foster. My background is that I'm actually a retired Anglican church minister, and started my interest in this whole climate issue because the churches got terribly excited about it. And this was about 12, 15 years ago. I read Bjorn Lomborg's book, Skeptical Environmentalist, which I assume some of you folks have read, which was an eye-opener. And I took it from there, really. My background, despite being a church minister, is in science. I have a degree in natural science from the University of Cambridge some years ago. I taught science in Nigeria for 6 years, up to what I think would now be regarded as first-year university level, so that's about where I'm at. I tend to do my talks in what I call a magpie fashion. I collect ideas. They're not, very seldom are they my own, but I try and pull them together and hopefully make it comprehensible to the ordinary man. Probably to most of you will think, oh, don't oversimplify it, but there will be a bit. Okay, let's get going on with this. And somebody vaguely better show. Oh, I better introduce Tom Harris while he's here.
Yeah, while he's
he is one of the co-organisers. He's working like mad. And Roger, who is, you can't miss him, because when he stands up, he's kind of handy to have in a crowd, because you know where he is. He's a co-organiser, to put it mildly, set up the website, done a whole raft of stuff. So I'd like to, anyway, thank them very much. But we'll proceed on. We've got 3 days, so here we go. No, I don't want to start. Right, let's start here. I like to begin with a good Christian verse. The heavens declare the glory of God, and the skies proclaim the work of his hands. And just in passing, one of the things in Genesis that God did not give man dominion over was the weather. Just a thought to leave it with you. There seems to be a belief that there is a perfect climate out there somewhere, just like in Camelot. Those of you who remember that English musical, we were told that everything did exactly according to plan. Of course, that is not the way. Going backwards in time, we have a philosophical pressure that is built up to where we are today. Others will know more about this than I, but I'm just sort of spading up one or two. Well, one in particular. The Reverend, I'm sorry to say, Thomas Malthus, whom, if you remember, did a mathematical calculation to say that if the population of the planet reached 400 million, we would all starve to death and die of disease. I'm happy to say he was wrong. Other people have been right, but been ignored. Dr. Ignaz Semmelweis, anybody can quickly volunteer what he is known for? Puerperal fever. In the 19th century, mothers being taken into hospital to have children were dying like flies because the medical students would come from the path labs and simply examine the women. Their hands were filthy, and before long, whole wards were being wiped out. Semmelweis spotted this, insisted that his students wash their hands before they examined their patients, and the death rates plummeted. No one believed him. They all said, we're not doing this. This is nonsense, all this hand washing. And he was sacked from this hospital. Why is that familiar? He moved to another hospital, tried to reintroduce the same ideas and the same consequences. The death rates plummeted. Again, we don't believe you. And they sacked him. And the tragedy is that he ended his life in a lunatic asylum, where he had been so obsessed with the deaths that it just drove him crazy. Another man on the other side of this, Trofim Lysenko, probably I need to say very little about him, but he persuaded Stalin that he understood Mendelian genetics, or rather dismissed Mendelian genetics. He knew how to make crops withstand Siberian temperatures. Millions died, and astonishingly, he died a natural death, as far as I can work out, in 1976. Another man, Alfred Wegener, I'm sure you guys know about this, plate tectonics. In the 1930s, he put forward the theory that the Earth is moving. Most people said, it's rubbish. I don't think he was sacked, didn't get that bad. But here's a classic case of someone standing out saying this is the way it is, and it turned out to be correct. I mentioned Paul Ehrlich. He was the one, incidentally, who the economist Julian Simon took a bet with about resources in the I think it was the 1980s. On a 10-year basis, he said, you can choose any 5 commodities you like, and I bet you, I think it was $10,000, or there was some, it was a reasonable bet. And with people like Paul Ehrlich, that in 10 years' time, they will actually, in real terms, be cheaper, because there will be more of these resources, or at least enough of them. They thought money for old rope, took on the bet, and lost. And it was through that Lomborg, who read that story and thought, surely that isn't right, began to investigate the state of the planet materially and realized that on the whole, Julian Simon was correct. However, our beloved Paul Ehrlich, it's not very kind to bring up past remarks, as many politicians know, but I cannot but help saying that false prophets abound in this area. Paul Ehrlich in 1981 prophesied that by the year 2000, half the species on the earth would be extinct, and by 2015, all life would be extinct. Sorry guys, we're dead. This is what the Bible defines as a false prophet. And there's a wonderful Old Testament scripture in Deuteronomy. You may say to yourselves, how can we know when a message has not been spoken by the Lord? If what a prophet proclaims in the name of the Lord, now granted Ehrlich didn't do that, but he did do it with great authority, does not take place or come true, that message the Lord has not spoken, that prophet has spoken presumptuously, do not be afraid of him. Very good advice, or to summarize it, one strike and you're out. A more sane scientist, and I think well worth writing over everything we do as much as any scientist does, no amount of experimentation can prove me right, a single experiment can prove me wrong. And that is how science should proceed. I'm moving on to what I call some climate myths, which when you come down to it, people will tell you it is the case, but actually when you press them, there's no real evidence to support it. A case in point is the belief that were the Earth to be warming, more extreme weather events will start taking place. This is the standard rhetoric one hears. And I base this very simply on Professor Richard Lindzen's very straightforward point on this. If we simplify the situation considerably, which I'm doing, from, as it were, the north to the equator, and the same to some degree is true of the south, of course. If the cause of extreme weather is the clash, essentially, between the cold north and the warm tropics, that generates the excitement in the middle. Now, if the Earth warms, what actually happens is that it's the poles that become much warmer, whereas the tropics perhaps rise by half a degree or a degree, perhaps become wetter. These things are all a bit chaotic. But the general point is that the temperature gradient has reduced. And as a natural consequence of that reduction, not surprisingly, you will have less rather than more extreme weather in warmer conditions. It's colder extreme weather that produces extreme conditions. The British know a little bit about this, the English that is. In 1588, the beloved Spanish decided the Armada would be a good move to invade Britain. And although Mr. Francis Drake, that pirate, privateer, that solid soldier, did some damage to the Armada, the main thing that damaged it was the incredible August storms that broke out across both the Atlantic and, of course, in the North Sea, which drove the Armada. It was driven right around the north of Scotland, and the shredded remains of that limped back to Spain. And a medal was issued by Elizabeth, and it's got the wonderful motto on it, God blew with his wind and they were scattered. Now this was in the middle of the Little Ice Age, and these are these extreme August storms. It's just anecdotal rather than, if you like, statistical, but it's a classic instance of extreme weather created primarily by cold, not heat. Another quotation from that period, John King, an Elizabethan preacher, our years are turned upside down, our summers are no summers, our harvests are no harvests. This is in the depths, of course, of the Little Ice Age that Michael Mann thought didn't exist. Well, we can, to some degree, test the idea that if it's getting warmer, that we should have more storms. Well, in fact, here's tornadoes, and one can pull on a number of statistics here. Really, there is no pattern. There are spikes, there are troughs. It's complicated and certainly not related
Notable,
to temperature.
Philip, that the spike there is in the cold year, the La Nina year 2008.
Yeah. Here again is general storm energy, both globally and in the Northern Hemisphere. Again, the pattern, there is no pattern, is the point. There is no relation to global temperatures. Polar bears, another great scare story, as we all know. Well, I think the polar bears are doing fine. If you want to know more details, Dr. Susan Crockford is one of, but not the only, person who's very interesting on this topic. One of the problems polar bears suffer from, no, that isn't one of their problems, that's what they like to eat, ringed seals. One of the problems those polar bears suffer from is too much cold. If the ice in the Arctic becomes too thick, there becomes a problem for these ringed seals. Ringed seals put their little seal cubs on top of the ice and put a little igloo over them to protect them, and then they burrow up from underneath to feed them. Very neat idea. So they all happen in disguise. The trouble happens when the ice they have to burrow through gets too thick. The seals therefore can't survive, or they move to where it's thinner. The polar bears who are relying on the seals start to starve. So when it gets too cold, very often polar bears start to struggle, which is an interesting upside down turning again. The myth is that it's the other way around. Patrick is going to talk a lot more about this, so I'm just throwing this in as a sort of stone into the water. The oceans, this ocean acidification idea. First of all, I quote, here's my magpie mind, Professor Ian Plimer, who makes the lovely comment, the oceans can only become acidic if the Earth runs out of rocks. Basically, the oceans are a buffered solution, and if you're a chemist, you'll understand what that means. In crude terms, those of you who remember your experiments in school days of testing for CO2, you used lime water. Do you remember? It's a calcium hydroxide solution. And you bubbled CO2 through lime water. And what happened? It went cloudy, milky, as it formed calcium carbonate, which is insoluble. But your teacher would then go on and bubble more CO2 through that solution. And the solution would go clear again, because the extra CO2 turned the calcium carbonate into soluble calcium hydrogen carbonate or bicarbonate. Now that's basically what goes on in the oceans all the time. The more CO2 that goes in, the more the limestone and so forth will tend to dissolve to form a basic solution of calcium hydrogen carbonate. So in other words, it's an ongoing buffer. Less or more, this evens it out. So if the Earth did run out of rocks, yeah, sure, you'd have a problem. Then, of course, there's the pause, or not the pause, depending on our English Met Office. Dame Julia Slingo has told us, oh, we just had a 1 degree rise in temperature, and it's all dreadful, and we're doomed, and it's the hottest year ever, and all the rest of it. She also said, oh, we haven't had the sea level rise that we're bound to expect as a result of this, so watch out. It's suddenly going to happen. I love it. When the models say that there's supposed to be so much sea level rise, and it doesn't happen, the models are right, and reality is wrong. Puts me in mind of the Hitchhiker's Guide to the Galaxy. Never mind. Then there's the issue of the weather stations, temperature stations themselves. Now, Anthony Watts did a survey some years ago of where a lot of the stations that are used are actually located, and made some very interesting results. Here's an instance of one in an airfield, which of course is a logical place anyway to have a weather thing, you need it. But look where it is. It's in the slipstream of taxiing jets. So from time to time, obviously, the temperature is going to rise way above the normal, so you tend to get elevated temperatures. Here's another one, which he came across way out in the Californian hills. There's the Stevenson screen. However, here is a great flat strip of tarmac. And in hot weather, most of us know, tarmac gets extremely warm. And you can imagine, therefore, the thermometer a few feet above the ground is going to be well overheated just because of the presence of that tarmac. And he found that, I think, in something like 40% of the instruments that were inappropriately located. And also, one of the things that the people who do these temperatures did was to cull the number of stations they used for convenience. This is the sort of average number of stations that were being used. And it's intriguing, though don't read too much into it, correlation is not causation, that when they culled them by a considerable degree in the early 1990s, strangely the temperatures started to shoot up. Well, it's not necessarily that the two are connected, but just worth passing. One point to make, I think, that all ground-based temperature averages, which is what they are still effectively proxies for temperature. For the simple reason that, of course, the thermometers are not spread evenly over the planet. and therefore an awful lot of interpolation goes on. The results are homogenized, and then you throw away the original, which means guesswork. So in other words, we're still only looking at a proxy, whereas insofar as we can have a proper temperature, it's only fair to say the satellite data is probably far more reliable as to what is going on most of the times. Bob Carter will recognise this, slightly masticated version of something he produced. Well, I say he produced, but he put in an article some years ago. Basically, in the last 6 million years, temperatures in a sense have been going down. There's been a slight warm rising to now, but basically we are cooling as a planet. I wasn't around 6 million years ago, but it was a little warmer then, apparently. Here is the last sort of 10,000 years, one of the versions of the ice core proxies, showing the Holocene warming with its spikes down as well. And here we are. And we are supposed to be worried. This is what sort of gets you. When you start looking at real history, you think, hang on, why are we worried? Well, here is the comparison between Hubert Lamb's sketch of the temperature for the last 1,000 years, the medieval warm period, the little ice age, and currently roughly where we are. Once again, the question is, if that's reality, why are we worried? Well, of course, Michael Mann produced a very convenient excuse for that, saying, well, actually, this is what it is, and now it's all shooting up. So we should be worried. My problem is partly a question of, well, we know, I won't go into too much detail about Mr. Mann, but in a sense, his science, so-called, compared to Professor Hubert Lamb, who was a man of considerable skill and talent. He's dead now, sadly. He was a man who knew his stuff, whereas Michael Mann was very much a new boy on the block, and other suspects, well, we know, I won't go into all that. Others have done it much better. Right, here's the issue. Is CO2 the most dangerous gas on the planet, which is what seems to be the implication? A colourless, odourless, life-giving gas, an essential building block for all life. As we all know, we are made of it. When we burn fossil fuels, I've got a piece here, I put it in a plastic bag, it's a lump of coal now, and we set fire to it. If it's oil, I couldn't illustrate gas very easily. It tends to be a little bit difficult to see. When we set fire to it, it makes stuff like this. And I remember writing to Michael O'Leary, who runs Ryanair, the Irish pilot who runs Ryanair, telling him that, roughly speaking, a ton of aviation fuel produced 1,500 loaves of bread. He rather liked that. No reason why you shouldn't think like that. There has been, in the last 35 to 40 years, and this is obviously a bit approximate, something like a 20% increase in the global biomass, because, of course, of the slight increase in CO2 causes vegetation to grow, and that's encouraging, it seems to me. One of the reasons why I say cutting carbon kills, because if you actually try to cut carbon dioxide, people who are living on the edge between survival and unsurvival will go over the edge because their crops will fail. So it's a form of genocide without, I mean, I'm not accusing them of deliberately doing that, they just haven't thought these things through. Here is a photograph of the greening of the Sahara from the south. The trouble is I haven't got an earlier comparison, but nonetheless it is greening from the south at the moment, which can't be a bad thing. One of the things about more CO2 with plants is that actually they require slightly less water to grow, because the stoma, the little mouths on their leaves that open to draw in and transpire out water vapour, don't have to open and close so often if there's more CO2, so they lose less water vapour, so they use slightly less water. So there's a double whammy advantage for more CO2. You can grow more, and you don't need quite so much water per unit. So that's an added advantage of more CO2. Now, the question of, it's all getting dreadful, CO2 has reached 400 parts per million, we're all dead. An idea, this is Coles to Newcastle here for most of you, you'll know all this, but one way of looking at it, if you imagine 2,500 people, they're their little heads and shoulders, of being the atmosphere. Of that, 79% of them is nitrogen, around just at 20% or under, is oxygen. The next most common gas is argon, at 1% of the atmosphere. Then, in relation to all this, that little gentleman there, little red man, is the representation of the amount of CO2. How much do we contribute, inverted commas, to that amount, ballpark? Well, to do that, you have to multiply your panel of 22,500 by 25 in order to find the single man that comes from human emissions. He's lurking there somewhere. Probably can't even. You can just see a little spark of red. That's our contribution. It's just a way of making people realise the actual scale of it. Most people don't know how much CO2 there is. Even intelligent, grown-up people, journalists, they don't know. I'm not saying all journalists, they don't know. A little bit of background here. This is to some degree speculation. Indulge me a little bit. If we think of the 4 rocky planets, our own, Venus, Mercury, and Mars, one of the things that's interesting is that it's very likely at the early formation of the solar system, the rocky planets attracted the heavier gases. And of those, of course, CO2 is the heaviest. It's 44, oxygen's 32, nitrogen 28, hydrogen is 2, water vapor is only 18, and so forth. Now, it's interesting to note that the atmosphere of Venus remains at 95+% of carbon dioxide and has an atmospheric pressure of 90 Earth atmospheres at the surface. A lot of the warming on Venus, besides being nearly half the distance to the sun, therefore gets more solar radiation, a lot of the heat on the surface is due to gravitational heating because of the pressure of the atmosphere trying to escape, but it's a squashing process going on all the time. It's interesting too that Mars still has 95% CO2 in its atmosphere, but most of that atmosphere was long ago blown away by the solar wind. And it's got a core, it hasn't got a magnetosphere, as far as I know, and so it's very low pressure, but it's still 95%. Mercury tells us very little because whatever it ever had has long gone, and whatever is there is not worth being relevant. Why does that matter? Now, this is where I move into the realm of somewhat speculative. It's not, again, based on my own ideas. It's based on a deceased geologist called Graham Oram, whom I knew. He died last year, very sadly, rather suddenly. And he put forward this hypothesis that the Earth began its life rather like Venus. Some 100 atmospheres pressure and almost entirely CO2 atmosphere. What happened to make the difference? What happened to make our amount of CO2 to be that? Well, we all know it's life. The cyanobacteria began it and sucked CO2 out of the atmosphere, turning it into organic life and then turning it into oils and gases and so forth, sequestering the CO2 in the biosphere or in the Earth. Now, this is all very simplistic and crude. What they also did, of course, by photosynthesis was to generate oxygen, which to some degree was a poison. From their point of view, it didn't matter. So oxygen increased as the CO2 fell. The atmospheric pressure was also falling as a result of taking the CO2 out of the atmosphere. It ceased to be so much pressure because there was less of it. Then there was what many argue was a global ice ball when CO2 was at nearly 40%. So CO2 obviously causes cooling as opposed to warming, but that's by the by. And out of that emerged, of course, the Phanerozoic age when life expanded in an extraordinary fashion, emerging from that period. Oxygen was considerably higher, between 40 and 30%, particularly for a very long span of period there. CO2 was falling because life was drawing it out. Pressure was also falling. However, in the very early period, about 500 million years ago, Carboniferous period, the arthropods, which were things like dragonflies, were huge creatures. 2.5 foot wingspan, you need a metre, if you're French. Well, 2/3 of a metre. They would have needed not only a lot of oxygen to maintain the energy in flight, they would also need high pressure in the atmosphere to enable them to actually fly because of their weight, body weight, wings proportion. Going further on in time, we have the flying dinosaurs and the flying creatures like that. Once again, they would not be probably able to fly today. Jurassic Park has its problems. We couldn't actually get the pterodactyls up there. They just fall out of the sky like a lead balloon. But of course, the pressure at that period was 3 or 4 times what it is now. And again, the oxygen, which they would need for this extraordinarily hot-blooded, because they were hot-blooded creatures, as far as we know, the dinosaurs, they needed that oxygen to keep going. So going back to that, during this long period of high oxygen, 30% plus, these creatures could exist. CO2 was still pretty high on this hypothesis, and there was a logical reason. Oxygen at 30% would spontaneously tend to ignite forests and plants simply because of the high oxygen, the oxidation level. They needed a fire extinguisher, and there was one there, CO2 in the atmosphere. Enough of it to reduce the risks. Welcome. Hi. To reduce the risks of forest fires, even at that period. Aha! Here's welcome. Finally got off the train.
Nice to see you. Could you please change places with your brother?
Oh, yeah, I'm working on that.
Nice to see you. Here's Corbin, weather action. Mark,
to the
going to be the cameraman in due course, is that the idea?
Yeah, we have a camera.
I'll get that for the next time.
Yeah, we have
We're being filming at the moment. So.
All right.
Yeah, that's all
Good
right.
to see you guys.
It's lovely to see you, but you gave a wrong address.
Oh,
It said Rue Roche.
Oh, well, no, it's
Roche
good.
Fruit Cup.
Go, yes, yes.
Straight up on the piece of paper. All right.
Okay, moving on, the CO2. Then came the impacts, which in themselves probably didn't kill the dinosaurs, but what it probably did was to shift the balance of the atmosphere, dropping oxygen from 30% to 20%, and that's what would have genuinely suffocated the dinosaurs. Over a period of time, but it would have taken time as they struggled with their hearts trying to keep warm and trying to have enough oxygen. So that probably killed off the hot-blooded dinosaurs, but did not kill off the slow, cold-blooded creatures that could manage by simply slowing their metabolism. That's a hypothesis, not a certainty, but it's moving on, which I'm doing. The belief that carbon dioxide drives climate change and that human emissions are greatly increasing this effect rests on the interpretation of 3 pieces of evidence. The ice core data, the modern rising levels of CO2 from somewhere around 0.03% to 0.04%, and the fall in proportion of carbon-13, a non-radioactive isotope of carbon, in atmospheric CO2. Here is a schematic, really, of the ice core records, with the temperature obviously in blue, and CO2 in green, and methane shifted up at different scales in sort of brown. And the famous Al Gore point was, oh boy, do those things not obviously link together? Well, they do, but if you actually look at the detail, and this is a crude way of doing it, and expand it out, what in fact you tend to see is that over that period, the temperature rises first, and then perhaps some 1,000 years later, the CO2 follows upwards. Remembering that the ice cores are very compressed and very smooth, so they're not going to give you year-by-year stuff at all. And methane follows the same sort of pattern. The likely cause of this is that the rise in temperature is what has generated the the increase in CO2. It's a natural thing, even if you think of it today. If the oceans, for example, warm, then they will outgas CO2. Warm drinks spew out CO2, fizzy drinks. Cold drinks don't. It's a point people forget. It's simple, basic physical chemistry. Gases dissolve more in cold water than in hot water. It's the reverse of most chemical salts. However, they claim that nonetheless CO2 was driving the temperature, but in fact James Hansen knew perfectly well that they did not. This is James Hansen speaking to a reporter on the 10th of October 1989. In fact, the CO2 changes do seem to follow the temperature changes, not precede them. That is from the horse's mouth, from the very man who told that Senate committee that we are all going to boil. These are his own words at the same time. And as I said, this is hardly surprising, as warming causes outgassing from the sea and more organic decay on land, a point I shall touch on in a few minutes. This comment was just 16 months after Hanson's infamous declaration to the US Senate that a catastrophic man-made global warming had started. And as some of you are well aware, that was a setup from the start. The Senate room in which this announcement was made had been so arranged. It was in June in Washington, which is a hot time for them. The air conditioning had broken down. People were sweating, literally, and doing this with their shirts. And Hanson told us, we're going to boil. Psychologically, very well done. Well, here is still our attic. Worked very well. Now the ice cores. One or two little points in passing about these. I'm no great expert on this. Here's my magpie business going on again. Here's a picture of them pulling out an ice core. Here's another one as they pull it out, in which you, in theory, can just about see the little bubbles of trapped air that have been accumulating in the ice cores over many hundreds of thousands of years. But a point that is sometimes missed, as I understand it, is that when you take an ice core out of the ground, literally as you're pulling it out of the ground, you have outgassing. Because at the bottom of the core, you've got huge atmospheric pressure. In fact, you've got the crushing weight of ice above it. The pressure on the air inside the ice is huge. Reduce it to 1 atmosphere, the ice cracks, the air gases out instantly. And I remember hearing someone who does this work, pulling out these ice cores, you can hear them fizzing as they come out of the ground. So in other words, when you measure the gases from the ice cores, you are not measuring absolute amounts. You've lost most of it. All you're probably picking up is a trace shadow of ups and downs. It's a kind of differential of the changes, rather than the actual amounts involved. This is partly based on Murray Salby, but on that sort of basis, even going back a few, 100,000 years, we could well be looking at a great deal more CO2 in the atmosphere than is claimed at the moment. 10 times, 20 times, perhaps. I mean, this is, to some degree, obviously, modelling, not measurement. You can't do the measurement, that's the trouble. Quickly through the global carbon cycle, and many others would be able to challenge and say, well, this isn't very good. Obviously, we have ocean, vegetation, and land. The oceans are exchanging CO2 with the atmosphere on vast quantities in both directions. These figures are obviously extremely variable. Sometimes a lot's going up, sometimes a lot's being sucked in, depending on the temperature of the ocean. The same is true on land. Massive amounts of exchange of CO2 between organic material sucking it in and rotting organic material letting it out. And at the same time, incidentally, letting out methane, because anaerobic decay, where there's not enough oxygen, tends to generate methane. Human beings are also doing this. We are burning fossil fuels to some degree and using farming techniques to take it in again, I suppose, arguably. However, the quantities involved in human emissions are order of magnitude at least smaller than the natural processes around us, which accounts for the fact that probably human emissions are 4 to 5% of the total. An additional point here is volcanism. On land, volcanism doesn't generate a great deal in terms of overall amounts. It does generate quite a lot. But what we do not know, as I understand it, is ocean volcanoes. And as far as we can tell, there are, again, an order of magnitude more ocean bed volcanoes and cracks and so on than there are on land, but difficult to measure, difficult to know. I opine at this point that in the deep trenches there is liquid carbon dioxide. Under cold and under pressure, it liquefies, which tells us something about the oceans as a whole, that a solute in presence of its solvent, of its solute, is saturated. In other words, if there is undissolved CO2 in contact with ocean water, it follows that most of the oceans are already permanently saturated in carbon dioxide. What goes on at the surface layer would obviously be much more complicated because of the disturbances and so on. So that's just it combined, so moving hastily on. Here is, and this is Murray Salby now, I'm just going to spin through this. Here is the temperature since 1958 up to about 2013, 2014. Here in the green is the CO2 emissions. The seasonal jaggedness is what you might expect. If you then get net global emission of CO2 and model it, and yes, it is a model, with surface conditions, primarily temperature and moisture, what you tend to find is that as surface conditions fluctuate, so too does the CO2 emissions, strongly suggesting that the CO2 that we see changing and increasing is due to natural emissions, particularly from vegetation, rotting, and so forth. The same is true to the carbon-13 emissions. Do exactly the same. Interestingly, plants do not take up carbon-13 as opposed to carbon-12. They prefer carbon-12. It's a slightly different size atom, so therefore they are slightly picky. And the argument is that because the CO2, the 13 emissions are falling, this is because we're burning fossil fuels, which of course is made from organic material. But of course it's equally true of organic material that is existing now. It too is low in carbon-13 by default. So it doesn't, the fossil fuel argument doesn't hold water. In passing, just like with the CO2 chart, the same model with methane. And one of the nice things that Murray Selby says is that the alarmists presumably have to claim that burning fossil fuels causes flatulence. Because if the CO2 and the methane are behaving together, clearly that cannot be, or at least it's unlikely to be, simply due to burning fossil fuels. We must be producing more methane as well. Well, I suppose they blame the cows. But now, yeah. Interestingly, human emissions from fossil fuels have done an interesting thing. From the 1990s, the rate of increase is that angle. From 2002, there's an almost perhaps doubling to tripling of the rate of increase of use of fossil fuel, mainly because of China and India, but other places as well. That is interesting. This is a step change upward, which you would expect if human CO2 emissions were driving temperature, you would expect that to have an effect on temperature. Let's go back to this for a moment. This is the CO2 temperature and so on, imposing on it a simple version of this change. What is interesting is, of course, one, that the temperature flatlined when our emissions doubled. At the same time, the rate of increase of CO2 slowed up. If you notice here that during the period of warming, the CO2 emissions were increasing on a quadratic scale, a curve upwards. At the point at which things started to flatline, that curving upwards began to become linear. This is what you would expect with a natural model of CO2 emissions from the land and the sea. Very simplified. Here we have it again, the temperature very crudely done, flatlining now, the CO2 emissions doglegging upwards, yet CO2 emissions have slightly declined and the temperature has flatlined. It seems to me it would be unreasonable to conclude that this sudden spike upwards in emissions of CO2 from men, human beings, has anything to do with either CO2 levels overall or temperature. This is borne out by satellites. This is not the satellite picture. This is a calculated picture of where, if human emissions are the cause of the increase in CO2, where you would expect to find, to some degree, accumulations of CO2 over, obviously, the industrial areas of Eastern America, over Europe, India, and of course China being very dirty, and to some degree Brazil. That's what calculated would be. That's a model, if you like. Here is the satellite observations. What in fact we find is that the CO2 emissions are almost entirely in a band in the tropics, where the maximum amount of decay and as well as growth is taking place. This is where naturally, if it were natural, you would expect it to be, and that is what the satellites find. Intriguingly, over the northern hemisphere, it looks as if we're actually as a carbon sink, but there may be seasonal reasons for that. But nonetheless, the point remains that the model does not fit the data. Another point they make is, well, yes, even so, the CO2 will take hundreds of years to be sucked again out of the atmosphere. That's what the UN models are predicting. We have, fortunately, in fact, thanks to Patrick to some degree, the Nuclear Test Ban Treaty. Exploding nuclear bombs, particularly in the atmosphere, generated a lot of carbon-14, that's radioactive carbon, which is very measurable. And of course, as all these tests were going on, the amount of carbon-14 in CO2 was rising rapidly as a result. When the Nuclear Test Ban Treaty was signed in 1963, then the fall in carbon-14 CO2 could be measured. And of course, it's a very nice downward, as you would expect, curve. And it means that it would be more than halved in less than 20 years, if this is correct. The IPCC UN model, on the other hand, predicts this hugely extended time for dissipation of excess CO2, even if it mattered. Whereas here is what you might call the measured version, much quicker. Quickly onto computer models. I'm doing okay. Here we have a summary of 102 models giving a simplified line here. We have two little dips, which the models apparently predicted. These, of course, coincide with the consequences of two big volcanic eruptions. The only thing to bear in mind is the computers did not predict them, not surprisingly, it would be expected to, so they were added manually. So if you take out the added dips that were put in manually, what we're looking at is a straight linear upward curve, which strongly suggests all the models are representing is increase in temperature equals increase in carbon dioxide. In other words, it's coming out with garbage, to put it crudely, which is what I would call it. Then this is a British model, of course. We've just spent £100 million on a new computer from the Met Office, which, as a good physics friend of mine put it in a conversation with then Julius Slingo, he said, this new computer of yours, is it just going to give you the wrong answer quicker? Which I thought was nicely put. Talking of the computer models, I am no expert, so I'm just borrowing my magpie way here. Christopher Essex has done a paper on this. You'll find it in the book there anyway. But he explained that one of the key things that you need in doing these computer models is a solution to an insoluble equation, the Navier-Stokes equation, which is a partial differential equation which cannot be solved. I mean, most partial differential equations can't be solved. Schrodinger's wave equation, that sort of thing. You just have to guess and play around and hope you can come up with something coherent. Now, the grid that, even if you are going to have a meaningful solution to the Navier-Stokes equation, you need a 1 millimetre grid of the atmosphere to get a point from every 1 millimetre square of the atmosphere. At the moment, the best they can do is about 1.5 kilometres square to solve that. And even if you could do that, and even if you could use a computer to hatch it around the Navier-Stokes equation, which looks like that, by the way, or one version of it, incidentally, one of the ways they tried to simplify it was to remove this term here, mu, which is the viscosity of whatever fluid you're talking about. They said, well, let's pretend it's naught, in which case the whole of this part conveniently disappears. There was only one slight snag, but when they started to generate their spinning model, and they then tried to put mountains into it, they found the Earth's atmosphere broke the sound barrier as it went over the mountains. Not surprisingly, because if you make viscosity zero, the thing's just going to go whipping around everywhere. So in other words, even the fudging doesn't really work. But how long would it take, with a millimetre grid, for a computer, you know, the best computers you could possibly imagine, banging away at this, how long would it take? The answer is 10 to the power 20 years to generate a projection for 10 years. There is a fundamental difficulty with this. It's the square of the age of the universe, as I like to point out to people. So, in other words, computer modelling is clearly something that should not be in the public domain. It's a kind of business that should be kept quiet in the best sense. There's nothing wrong with modelling, and there's nothing wrong with playing around with them. But for goodness sake, don't tell us the answers, because they are bound to be wrong, and have proved to be so. So our influence, our climate is almost beyond human influence. The main influences are, and Piers will talk a bit more about this, he may or may not agree on the cosmic ray side, but that's a different issue. Lunar orbit, planetary orbits, our varying position in the solar system and in the galaxy, and on Earth, The clouds and the ocean currents control the overall temperature, not the other way round, and they respond primarily to these extraterrestrial influences. So I always like to say the weather doesn't come from the Earth, it's actually brought to the Earth to a considerable degree. So we really are not going to be very good at controlling it ourselves. Here's just a nice little throw out. Want to worry? Here comes the next ice age. Well, prediction is not my game. I don't want to fall into Paul Elliott's trap, but this is somebody else's prediction that we are due for another big, serious ice age, not just a little one. But we don't know. It could be plus or minus 10,000 years, so it's a wee while to go. I like Professor Richard Lindzen telling our English Parliamentary Committee, discussing this lovely line: whatever the UK is doing about climate change will have no effect on your climate. It will have a profound effect on your economy. And his other remark: it is clear there is no policy that is better than doing nothing. Which I think is succinctly and nicely put. However, back to Malthus and others, we have one of our English TV pundits, a chap called Chris Packham, who runs Springwatch and all kinds of things, and I owe James Dennypole, who's had to leave, this lovely quote. When asked which species he wouldn't mind seeing extinct, he replied, human beings. No question, that's the only one, which is nice to think about that. But it's this kind of curiously inverted view of human beings that seems to march through a lot of this, from Malthus to some degree, and right the way through this agenda. It's human beings are the problem, not...
Loads of human beings, that's what
Yeah, well, you know, which one of these people ought to volunteer, but I'm not favouring euthanasia. From a Christian perspective, I like to throw this in, and it is from my perspective, that the earth was made for man, not man for the earth. I'm paraphrasing something Jesus said about the Shabbat, the Sabbath. The Sabbath was made for man, not man for the Sabbath. In other words, it was for his good that God made the Sabbath day, not something to enslave him and make life impossible, which it had become for the Jewish people. So I would say the same. God made the earth for man to enjoy. Yes, we've abused it. That's a different issue. And Patrick is an expert on this, and most of us know about that. That's because we are fallen, disobedient human beings. But it's still God's gift to human beings. And if we treat it the other way, we'll end up worshipping all kinds of weird and wonderful things. Why has this happened? And I'm going to finish in a moment. The collapse of the Berlin Wall coincided with the sudden rise of the concern for global warming. 1988, 1989 was the switch round period. Why? The fear of the Red Menace evaporated. Human beings feast on fear. We need to have something to be afraid of, and politicians are very good at trying to find something to make us afraid. And there's nothing better. You are to blame. So that is an interesting turnaround point in modern history, the collapse of the wall. I borrow a number there, but I think I'll stop at that point. So, so gentlemen, I'm finishing there. I did start a little after past, so if people have got some questions, queries, challenges, now would be a good moment.
No questions.
Bob's going to blow me over the water here.
I'm interested in the psychology of parliamentarians, not just British parliamentarians, but seeing as you give us those two quotations from Dick Linsky,
Yeah.
and knowing Dick's impeccable scientific reputation, how is it possible for an expert committee of a major Western country to just ignore them? I mean, you don't need a degree in science or a complex understanding. Those are very simple, absolutely true statements.
Yeah.